This lecture is on time value of money basics. What I will do is I'll start out with the assignment that you will do. I will show you what that is on the Word document, and I will then follow up with a brief PowerPoint discussion talking about the basics of time value, and then I will use Excel to show the formulas in Excel and how would one use it to do the time value. And those are the types of formulas in Excel that you will need to do these assignments. So starting with the assignment. The assignment has basically, the first one is simple. That has to do with what if Mary has $10,000 in the mutual fund and she expects the money to grow 6% a year. How much will she have in the future year? And your job is basically to say, okay, if I have $10,000 in 2001, how much will I have in 2002? And so using Excel, calculate how this base amount will grow at 6% a year. Okay.
The second assignment is, what if Julie plans to put $200 every month for the next 20 years in her percent a year? How much will she have in 20 years? Be able to have your independent variables to be the R, PMT, which is the amount of money she's putting in. And in some cases also, if you have, it is basically asking you to do is to say that if she is putting in $200 every month for the next 20 years, and if the growth is expected to be 6% a year, what's going to happen? So you basically are going to calculate the future value portfolio, again using Excel, and I will talk about that formula calculations. And that is, if John plans to borrow $200,000 to buy a house, let's say the current interest rates are 5% in this example. It's basically, I've done the formula for you to show you, so when you do it, you should get the monthly payment to be $1,074. How much will he pay over the life of the loan to the bank? That would be $386, $512. How do you get that? This basically you get it by looking at the monthly payments he's going to make, which is $1,074 for 30 years times 12 months, and you get that number. So this cell should be this number times 30 years times 12. And off that, how much is he paying interest to the bank? That this number would be the total amount he's paying. Again, that is monthly times 12 times 30 years. You get that number. And off that, you subtract the principal that you borrowed and the difference between the total you will pay and the principal you borrow. So he's paying $186,000 in interest over the life of the loan. So the assignment is do the same thing except do it for 20 years, 15 years, and 10 years. So these are the three basic exercises you are going to do. Now, next thing I'll do is to talk about the basics of time value of money, and then I'll just open an Excel file to be able to show where these formulas are and how would you do it. Okay, so let's start with the PowerPoint. So this is a basic time value conversation. When you come to the finance class in the MBA program, MBA 634, we will get into more detail. So basic finance, time value of money. There are 4 parameters to think about when you're looking at a time value of money on this chart, and there is a 5th one, then I will talk about it in the few slides. So the 4 here are present value, which is the money that you have today. So for example, in the case of the first homework assignment, Mary had $10,000, so that was the present value. The future value is in the future,
how much will that money be? And that will depend upon the time horizon, which is the N, how many years or how many periods or how many months, that is the N, and the growth rate, which is at what growth rate will it grow. So again, the example of the homework assignment is that she has $10,000. Next year would be year 1, so N would be 1. Future value will be 1 plus 0.06, which is 6% growth rate, and you would get the future value. So if you want to know the future value at any point in any N, you start out with the present, and you look at the growth rate, and you account for the N. So the formula is present value times 1 plus growth rate. Growth rate, if it is 6%, means it is 0.06. If it is 5%, it would be 0.05. And that gives you the future value. Okay. On the other hand, if you knew the future value, let's say somebody said, hey, you will get $10,000 in the future, and you want to know what is it worth today, you basically are going to use the same formula, but you calculate the present value by using this formula. Now, the formulas I will have you calculate with the calculator in the class if you feel comfortable in the finance class. As the intro level class, I'm more focused on the concept. So we will basically use Excel formulas to do that. So all these formulas that I'm talking about are embedded in the Excel calculations. Okay. So continuing with the concept, if somebody puts in an amount of money, say $2,000, for 3 years, 1, 2, and 3. If you want to know how much will that be in 3 years, you basically take in the money, which is the present value, times 1 plus the growth rate, in this example is 5%, raised to 3, you get that number. If you put the money here, obviously you'll have less time to grow. This one will have less time to grow, so you're basically multiplying it by the growth rate raised to the N. The number of years is going to compound, number of years is going to compound, and so on. One of the things when you're looking at time value of money, you also have to think about is, when are you putting the money in during that period? Let's say we're talking the period as a whole year. And period could be a month, could be a quarter, but let's say we're talking about a whole year. So the question is, the $2,000, when are we putting it in? So let's say T0 is 2011, last year. Let's say T1 is next year, which is 2012, 2013, and 2014. So now if you're putting in this amount of money, in this example, $2,000, when did we put it in the year 2011? Did we put it in at beginning of the year, the January 1, 2011? Or did we put it at the end of the year, at December 31, 2011? And the reason that matters is that if you're putting it in the beginning of the year, during that year 2011, you'd also get the compounding. On the other hand, if you're going to put it at the end of the year, into December 31st, obviously there is no time left for compounding. So the only compounding you will get will be for the future year, in this example with 2012, 13, and 14. Now, in time value of money, the default typically is that you assume that it's going to be the end of the period, the end of the month, end of the year. And so if the problem or the situation is silent on the when, then it assumes the end of the period. But if it is not, then obviously you have to account for one more year. So when we get to the Excel, I will show you that when you open up the box for the calculation, there is a box that will allow you to do is at the end of the period or is it the beginning of the period. But I want to bring it up from the conceptual perspective over here. So when I bring it up with the Excel file, it'll probably make more sense. So again, if I want to know how much will this grow, it'll grow X number of periods. If it is put at the end of the period, then it's only 3 years, 1, 2, and 3. If this was the beginning of the period, this number would be 4, and this would be 3, and this would be 2. And hence, the punchline is that by doing it at the beginning of the year, as you would expect, you are going to grow the money for 1 extra year. So again, when I do the Excel, I'll bring it up again, but at least you will know. With this conversation, it will become probably a little bit more clear when we get to the Excel example. So now, the other thing I also want to talk about is to say, okay, what if there is a situation, like in this example we just did, the numbers every period are different. 2,000, 3,000, 4,000, 5,000. And if you want to do that, you have to calculate each one of them individually, figure out what happens in the future, and then you're going to add them up. If the numbers are exactly the same, let's say $1,000 each, in that case, the mathematics becomes a bit easier, and then you can go in and be able to use the formula that I will show you. But the logic is still the same. This one will grow for 1, 2, 3 more 4 years left. This one will grow at 3 years, 4 years, so on, and we add them up, we get 5, 6, 3, 7. So you can do this thing one at a time. But because the numbers are exactly the same, there is no year where the number is different. You can use a formula, and that's what Excel does also. So what is the formula? The formula is that if I want to know the future value, and if I know the PMT, the amount that we are putting it in every period, then I can use this formula, 1 plus R. R is the growth rate, N is the period, minus 1 divided by the growth rate. So if you're doing it by calculator, and I'm not expecting you to do it now in this class, you will in the finance class, is that PMT in this example would be $1,000. 1 plus R, so it would be 1 plus 0.06. So this parenthesis will become 1.06. You're going to raise it to N, which is 5. Whatever number you get, you're going to subtract from it 1. Whatever number you get, that you will divide it by 0.06. And you will get future value of 5637. That's what you will get if you do calculator or if you get a finance calculator. Excel, we can do the same thing. We'll talk about it. But conceptually, I want you to know if the numbers are exactly the same, then we can use this formula because then it's only one amount to think about, which in this case is $1,000, which is called the PMT. If the number would be 1,000, 0, 1,000, and that will not work because then we have one of the years which is not exactly $1,000. Okay, so now let's look at the Excel. Now this is a screenshot. I will show you the screenshot and then I will open up an Excel file. This is a screenshot is that if I would go to the formula up here, then I would go to the financial formula over here. If I scroll down and I'm looking at the future value, click on it, this will open up. When you open up, you will have the place to put in the rate, which is the R, and number of periods, and PMT, amount of money every period. And if there is a present value starting out with, and in the examples I've given you, there is none. But if you did, you can do that. And the type is, this is where it's going to ask you if it is end of the period or the beginning of the period. So again, this is a screenshot. When I open the Excel file, you will see that as I move the cursor around, it'll tell you what exactly each one means. Okay, so let's open an Excel file. So now I'm opening an Excel file, and this is just the empty Excel file. I just want to be able to show you where the formulas are. So if I click the formula right here, you got a bunch of tabs open up. We're looking at the financial formula, so click that. You'll go down into future value, which is right here. So you clicking it, again, we got it from formulas to financial formulas into future value. Click that and this box will open up. And that's what I had in the screenshot. Depending upon where your cursor is, it will tell you what this information is over here. Okay, in this case it's R. But also pointing out to you and reminding you that depending upon how the periods are and the payments are, the R and they have to be in sync. What do I mean by that? Let's say if you are talking about putting in money every month. So it is monthly. So PMT, whatever you're going to put it in, let's say you're talking about putting in $500 every month. So that's what we're putting it in. Okay. And because it is, and let's say we will do that for 30 years. 30 years in a row, we're going to put $500 every month. So now the period will be 30 years, 30. But because it is monthly, we have to account for 12 months in a year. So we're going to multiply that by multiply times 12. Okay. Sorry. I'll do it again. I just went too forward a little too much. Hang on. Future value again. Again, the monthly will start again over here. $500 every month. And number of periods is 12 times 30. 12 months, 30 years. And let's say that we expect this mutual fund to grow at a certain rate, and that could be based on historical perspective mutual fund. Let's say we assume it's going to grow at about 6% a year, so that would be 0.06. And because everything is monthly, and if the rate is annual, then we have to divide it to get a monthly rate, so we divide it by 12. Okay, so now you'll get a answer right here. Okay, because I was doing this thing, if I do okay, I'll get the answer right here. Okay, and that's what the answer is now. Now you're going to say, hey, how come it is negative? The reason it is negative is in a time value of money, there are two elements. One is money putting in, one is money coming out. So when you are investing, you're basically putting money in. That means you are giving up money. So that's why your money is typically negative. So in order to get this thing positive, and again, that's just a nuance, but let's go just so you know it. So for example, let me just kind of make it easy. Let's say we had a rate R, and this R is we put R here and put a cell right here. Let's say it is 0.06 annual rate. Let's say we're going to put a PMT of whatever number we want to put in, let's say 500. Let's say we have, currently we have no value, which means we have nothing in our accounts, so we'll put a 0. And then we want to do is to figure out the future value. And so we will go, and so we got the R, we got the PMT. Now we got to do is to put the N. Let's say we're going to do it in years. So let's say we're going to do it for 30 years. Okay. So our assumptions are that we are putting in a 6% growth annual, monthly payment of 500, nothing in our account right now, and we have N equal to 30 years. Now I'm going to go in and do the formula. And we want to do is to figure out what the future value will be right here. Okay. So I click here. I open a formula to the future value. And now I need the R. R is right here, this cell, but what I want to do is, because payments were in monthly, R has to be monthly, so we divide it by 12. Then I come over here, periods is going to be 30 years, which is this, but because it is monthly, we're going to multiply by 12, so we get, per month times 12. Payment is right here, it isn't monthly, so we plug that in. And let's say we got nothing in the future. And here is the type I was talking about before when I was doing the PowerPoint. So if you read right here, type is a value representing the timing of payments. Payments at the beginning of the period is 1. Payments at the end of the period is 0 or omitted. So the default is always end of the period. So if you don't put anything, we'll assume it's end of the period. Okay, so let's assume that for right now. So we say, okay. So this is what we get. Remember I told you before about starting to talk about the minus sign. The reality is, because we are putting the money in, which is the cash outflow, which is the negative for us because we are giving up the money. If we make this a minus 500 instead of 500, this number obviously will still be the same. You can see, as I had done before, it'll still be the same, but it's going to be positive. Now, does it matter minus positive? The answer is no. It's just that you should recognize that the way time value money works is that when you put it in, when you take it out, taking it out basically implies it is positive, putting it in basically implies negative. So that's why you'll get a negative number. If you get a negative number, it's not a big deal, but that's why you get it. If you make your number negative over here, this will become positive. Now, here is a value of this kinds of analysis. What if somehow we can put in a little bit? So right now, basically this says that if I put in $500 every month for 30 years and the fund grows at 6% a year, and I'm starting with nothing, my present value is 0. I can make 502,257. What if I also had some money in the bank right now? Let's say I had $20,000 already in the bank. So now I can put in present value. Okay. Now, as you can see, it did not change. Why? Because when I did the formula, I did not put the cell in. So let me go back. Go back. Future value. This time around, I'm going to include that in the cell. So again, R is this. We want it monthly, so divided by 12. N is this cell. Payment. N is this cell times 12. Now 30 years times 12. Payment is what I'm putting it in, which is this amount. And again, negative because you're putting the money out. This time around, I want to put a cell in to say, okay, I also have, financial formulas, future value. Okay, so I want to do this again over here so you can see the difference. So now this time around, over here, I did not account for PV in the formula. Here I will. So I'm going to start again. Financial formula. Present future value. R is this cell divided by 12. Number of periods is this cell times 12, number of months. PMT is this cell. Present value, this time around, we're going to put in the number. And we get, and again, it should be minus, obviously, forgot, because we're putting the money in. So you can see that if I also had money today, it will also grow. So again, let me summarize it. What we're trying to do is to figure out the future value. We need R. We need the PMT. If there is a present value in the future, in the homework, by the way, I have not given you the present value, so that would be 0. And then the N is the number of periods, and then we can figure out. So this basically says is this. If somebody puts in money $500 a month, every month for the next 30 years, and right now they're starting out with $20,000 in their account. Remember, these both have to be minuses, okay? Or you can put them both pluses and then your answer will be negative, but these have to be consistent. So I recommend putting minus, minus, and this is what you're going to get for the answer. Now what happens, somebody says, I think I can add, maybe instead of 500, I can do $520. So let me say minus 520 and see how much it grows. So it goes, just adding another $20 a month for 30 years. By the time we get to the end of 30 years, we have now much more money, $642,000. It becomes a very useful tool to do that. So when you're using your calculation for the formula, that's what you're going to do, okay? The next thing I'll do is to maybe go do an example on the mortgage. Okay, so now let's talk about typically what would happen in the mortgage. Well, in the mortgage, we will have a principal we're going to borrow. So let's call it principal. Let's call it 200. Let's call it 150,000. Okay. And obviously, there is going to be R. Let's say we can borrow it for 5%, so 0.05. Period, obviously, let's say it's period, let's say it is number of years is 30, so that's 30, okay. And now we're trying to figure out is what would the monthly payment be. So that's what we're trying to figure out right here. So we know we're going to borrow 150 at a 5% rate, and it's a 30-year mortgage. Okay, and we're going to try to figure out what the monthly payment will be. So we go to the financial, this time around, figure out where the PMT is, monthly payments. The PMT, so we go right here, PMT. The box opens up. R is going to be this, but again, we're talking about monthly payments, so it's going to be divided by 12. Periods is going to be 30 years, because we're going to get monthly payments, it should be times 12. There is no present value. The present value, the money we are borrowing is 150,000. So that's the amount right here. And that says that on a monthly basis, we will have to pay $805.23. Now, this is again a very useful tool. What if I can go get a better rate, get a 0.04% rate, 4% rate? If I do that, boom, obviously I'll pay a lot less. What if I can, what if I decide to pay it in 15 years, so make it 15 years, obviously I'll have to pay more per month because I want to pay it off earlier. and just need more spaces for decimal. I'll have to pay 1,100. So this becomes a very useful tool to do mortgage calculation. Okay, now if I want to know how much did I pay to the bank, paid to bank over the life of the loan, okay, which means let's do again 5% just to get a 5%, and let's say I'm doing 30 years. Okay, I'm going to pay 805.29 for them. How much will I pay to the bank over the life of the loan? Well, I'm going to pay this much. I will pay this much for this cell, just 30 years times 12. So I'll be paying $289,000, 883 to the bank over the life of the loan. How much of that is interest paid? Interest paid will be this amount that I am paying. Then I am obviously getting the principal from the bank. So we are paying $139,000 over the life of the loan to borrow $150. And that's why they say typically, obviously, you pay as much interest as you do for the principal, on the life of the loan. Now, obviously, now what happens if we have to do is to try to pay earlier? So let's say, and I keep an eye on these numbers. Okay, all I'm going to do is to change the period from 30 years to 15 years, and you're going to see the amount even though your monthly payment will go up, as you would expect, because you are paying more per month, but because you're paying per month, over the life of the loan, you'll pay a lot less interest. So let's make this 15 years. So you can see that I'm only paying $63,000 on interest, whereas before we were paying $138,000. What if I can pay it in 10 years? See, down $40. And so obviously that's the time value of money is longer you take to pay them back, more interest you're going to pay. Quicker you pay, you're going to pay less interest. So this is what you'll be using again in your exercise. So again, how would you find all this stuff? You would find under the financial formula, you're looking at the PMT in this case, and so on. And you want to make sure that you can change these things, and it gives it to you so this can very easily be able to do that. Okay, so use this, and then also do the homework assignment. It'll help you understand this concept.